Hi everyone, and welcome back to the grand finale of developing an automation system that allows the fun to find us instead of us finding for fun. If you want to check out the previous two parts of this series, you can find them in the description below. But if you just want to follow along and learn more about the magical things you can do with GitHub Actions and coding best practices, you can grab a copy of the code in the description as well. Let's first review the one-sentence summary (OSS) of this project again, a service that sends an SMS message to me about the latest events that are happening in the area weekly. While the sending SMS and pulling latest events have already been done easily using Python, the tricky part is the weekly automatic trigger. The intuitive solution for this is to have a laptop on 24/7 and have automation run our Python script at 7 a.m. every Friday. The good side of this is that we can use any kind of laptop. It can even be a Raspberry Pi if you have one around, as long as it has an internet connection and enough power to run Python script. The bad side of this is we need a whole laptop on 24/7 to do just 3 minutes of work every week, which is frightful for the wallet and the environment.
Look, up in the sky, it's a bird!
It's a plane!
It's
GitHub Actions. Yes, it's GitHub Actions, an unexpected service from GitHub which came to Earth with world-class CI/CD far beyond others. GitHub Actions, which makes it easy to automate all your software workflows, fights the never-ending battle of making code reviews, branch management, and issue triaging work the way you want. Now we're going to use GitHub Actions to trigger a weekly task for free. The first thing we need to do in this video is to compose a script using the exploratory code we created from the previous videos in Jupyter. If you are wondering why we were using Jupyter, it is because Jupyter allows hassle-free trial-error coding, which is super handy when you want to quickly code out the basic logic of your idea. Anyway, coming back to making a script, the easier way is to have Jupyter and Visual Studio Code open side by side. On VS Code, create a new Python script. We will call it main.py. The first thing we want to do is to import all the necessary libraries. We can do this by just copying all the imports that are scattered throughout the Jupyter file and pasting them into our main.py file. You will then probably see VS Code complaining about all the unresolved imports. It's because it doesn't know about the existence of our project's virtual environment that we created in the first video called Twilio Scraper. Luckily, we can fix that easily by clicking on Select Interpreter and select the one with Twilio Scraper on it. And voila, all warnings are now gone. Also, a little pro tip if you want to improve Python development productivity, such as making these messy imports look better. You can create a project settings file inside VS Code and paste in the following settings, which you can find in the GitHub link down in the description. It uses Flake 8 to catch common coding errors and Black to enforce a consistent coding format. And yes, you will have to install them, but they are only a few kilobytes in exchange for a much better coding experience. Let me know if this tip helps you and if you have a favorite Python productivity library down in the comments below. Coming back to our main script, if everything sets up correctly and you click Save, the imports will be magically transformed into something more readable. And because imports are now sorted, this will help review code faster when you are working in a team. We are seeing some red right now due to all the imports not being used anywhere. But don't worry, we're gonna fill them up soon as we move on with our Jupyter file. With all the necessary libraries imported, now we can just do the simple job of copying the code over line by line. We will be making some small changes along the way to keep the code organized, but the flow and the logic will be intact. We first copy over this driver line. By the way, I will be opening and closing the side panel throughout the video to see the code in full screen by clicking Command B. If you remember from the last video, this line of code spins up a Chrome browser window for scraping purposes, but when running on GitHub Actions, there will be no screen for a window to open. So what we can do is run Chrome in headless mode by adding options like this. Headless mode allows Chrome to run without a screen while still allowing us to query HTML code like normal. Then we continue bringing the code over to our main.py. A data class. Since this defines the schema that developers will reference often throughout the development cycle, we will separate it into a different folder called Models to allow quick access and declutter our main business logic. The best practice for this is to have one file per data class with a file name matching the class name. For anyone who hasn't watched the previous videos, we refer to this as an article. Same for this, and this. Remember, we are going to have to import the data class again because we are in a new file, but VS Code makes it easy by just clicking on Quick Fix and choosing the appropriate suggestion. You will see I use this feature for quite a lot throughout the video. Let's resume copying the code over. we have to import the article now that we define it in a different place. For lines that are purely for displaying purposes like this one, we can just skip it since it provides no value to our production build. This line is only looking at the first article and sending suggestions from that article only. What we want is separate SMS messages for each article, which can be easily done by changing it to a for loop instead, like this. And since all the code down below digests one article, all the copy and paste from now will be inside this for loop as well. By now, you probably see some code duplication such as redirecting to a page, but we will do the second iteration of refinement after this. Let's continue the easiest job ever. Again, let's make a file for this data class. Suggestion represents this information in an article. An article can contain one or more suggestions. The last portion of the script is straightforward, so I will speed it up to save you some time. Great, diligent work. This script will work perfectly fine after you replace your credentials. However, if you want to come back to this code a year later and still understand it, we have some final refinement to do, such as creating modular functions and services complying with a single responsibility principle. If you want to skip through this, don't worry, I'm not offended. Well, maybe a little bit. Feel free to click on the next chapter. We can now maximize only the VS Code window since all the transferring is done. Let's start small by removing unnecessary imports. We don't want them just hanging there and confusing people. The first thing we want to do is to create services to further declutter our code. The first service is one responsible for handling all business logic related to browser interaction, such as page navigation. A service is just a fancy way of saying a model with methods. And for quick navigation purposes, we are making a new folder for services as well. For a browser interaction service, we will call it browser. Since we are doing some copying again, we can split the window by dragging the file to the edge of the screen, like this. We start with the usual data class import and class declaration. If you remember, all browser interactions revolve around the WebDriver, so that will be the only attribute we need for this service. Next, we declare its two methods, init and navigate-to. Init will spin up the headless browser and prepare the browser ready for action, and navigate-to will accept an URL, navigate the browser to that URL, and return the parser for that website. Finally, copy all the necessary imports. Coming back to the main script, let's utilize this new service by creating an object of this service. You can see VS Code is super smart and it can auto-import the service for me. You can now remove this line. The same thing for these lines. They can be replaced with our navigate-to method as well. Let's clean up the imports now that all the browser business logic has been organized. We still have to create two more services. Can you guess what they are? Let me know down in the comments below your answer and what's your reasoning behind it. The second service is one responsible for everything Google Places API. So let's create a service file for that. And just like in browser service, we need an attribute to keep track of the client connection we have with Google. And we will establish the connection in the init function as well. In the production environment, we would want to protect secrets like this, which can be easily done with a .env file and python.env library. Make sure you install python.env, then we use these two lines to read in secrets every time our script runs. For the .env, this is what it will look like. With that setup, we can now use this to retrieve the actual secret. And now you can push code to GitHub without exposing your precious API keys. If you remember from our previous video, we used three main methods from Google. We will provide some wrappers over these methods to make our code readable in this service, starting with searching for place ID by name. Then we create a method to retrieve open hours. And last but not least, get the estimated ETA and recommended travel mode. With all these methods helping us, we can now clean our main script. First, create a Google Places object. We can now use our methods. While we are here, let's move these two lines inside the for loop to correctly get open hours for each suggestion. Sometimes we may not find the destination ID, so we will provide a check here as well. And now we can remove Google Maps import in our main script. Hopefully by now you catch up with the rhythm and can guess what our final service would be. That's right, the last service we need is Twilio Service, which is responsible for sending SMS messages. Again, this service is very much like the previous two. It also needs an attribute holding the client instance, and of course, a method to send SMS. Let's plug this in our main script like before. And of course, removing Twilio dependency. Our program looks clean now, but remember, writing a program should be like writing an essay. It should have an opening, then passages, each focusing on one topic, then a conclusion. In Python, having an opening means having this. And as you can probably guess, our essay has 3 body paragraphs. The first is getting the articles. The second is getting the suggestion from one article. The third is building a message out of one article and sending it. Let's create the first paragraph, getting articles. This is how to create a second paragraph. And this is how to create the last paragraph. With all the components ready, we can now create a full essay like this. And that, my friend, are the best practices for any programming project. Let's run the script to quickly verify the changes. For the final part of this video, we will focus on getting this script up and running automatically at 7 AM every Friday on GitHub Actions. This is pretty easy, as all we need to do is to create a main.yaml inside workflows inside .github folder in our project root folder. GitHub will look into the workflow folders and follow the instructions listed in the YAML files there. First, we want to declare a name for this action. This is optional, but I like to name things for easy identification. We will call this automated fund scraper and sender. Every YAML needs an on key, declaring the trigger of the action. We want to run this on a schedule, and we will use cron expression to specify the date and time to run. Cron notation can be weird at first, but this website here is incredible if you want to verify your expression. This is the expression for 7 AM every Friday. However, GitHub Actions use GMT, so make sure you offset the expression by the appropriate amount. As I am in the EST time zone, which is 3 hours behind, I will have to offset the expression by +3. We also want to be able to trigger this action manually just in case, and adding workflow dispatch will allow us to do just that. Lastly, we need to specify the details of how to run the script from a new machine perspective. First, we want to create a job by defining the jobs key. Then defining this job to be deployment type. Next, we specify the machine to run the script on. Ubuntu is usually the best option because it is cheap to run. Then we want to define all secrets that the script needs, which we will configure on GitHub later. And lastly, the step-by-step command to run the scripts inside the steps key. Since it's a new machine on every run, we need to install the necessary dependency. We can do this by first getting access to the code by doing this. Then we install Python. Yes, the machine is really that fresh. Then we install Python dependencies using the requirements file, which you can download in the description below. Last but not least, run our main script. And that's it. All we need to do now is to push this codebase to GitHub and start chilling. Make sure you put in all your secrets by clicking Settings, Secrets, Actions, New Repository Secret, and you do that for all of the secrets. You can verify the workflow by going into Actions. Click on the created action name, manually trigger the action by clicking Run Workflow, Run Workflow. And that concludes our project. We did it! If you enjoyed this video series and learned something valuable from this, make sure to hit that like button to support this channel. Let me know down in the comment section if you want to see more of the same video format. Also, let me know if you have any trouble following the tutorial, and I will be more than happy to help. Anyway, if you want to stay up to date with the latest technology programming-wise that I'm gonna cover, make sure you hit that subscribe button, turn on the notification bell, and I will see you in the next video. Peace.